Hey Techno Studs, in this video we're going to talk about what I'm calling QoS Tools, the different things you can implement on your network to create great quality of service for the different traffic on your network. So let's get into quality of service tools. We'll start out this video by going a quick overview of what are the different tools. Then I'm going to get more in depth into each one of those tools. So we'll talk about classification, we'll talk about marking, we're going to get into policing and selective dropping, we're going to get into queuing, we'll get into scheduling and shaping, and then we'll wrap up this video by talking about tool selection, what it is that you would implement. This is the model that we're going to be using through the rest of this video and really for the rest of this module. For the rest of this module, we're really going to be talking about that differentiated service. That last strategy that we talked about in our last video is what we're going to be implementing and talking about through the most of this module. And this is the model that represents that. Right, so what is this model telling us? Well, this is representative of any type of piece of equipment, networking equipment you have out there. Whether it be some sort of wireless LAN controller or a switch or a router or a firewall, you're going to have some sort of ingress port, and it's going to do some processing and then it will have an egress to it. And so what happens in between, well, first of all, what's coming into it is a bunch of data, a bunch of voice packets, a bunch of video packets, a bunch of stuff coming in at all different times on different ports and really quite random for the most part. And so what needs to happen is there's a classification that happens here. And then possibly we do some sort of marking of that. So this is the classification and marking area right here. Then we get into congestion avoidance, where we're going to avoid congestion, and we do that through policing and selective dropping. And then we get into congestion management, and that's where we talk about queuing, and we'll talk about scheduling and shaping. And so what this video really is going to do is just going to do a quick overview of each one of these categories and what they are, what's happening in each one of these. And then we're going to have other videos in this module that are going to get more in depth into each one of these. So let's get into what these different categories are and what they mean. We've already discussed in another video of how there's certain traffic that really is prone to problems if there's certain delays or certain jitter or certain bandwidth issues, and phone voice being one of the more sensitive ones. Same thing with video being one of the more sensitive ones. There's some data that is more sensitive and other data that is less sensitive. So each one of these traffics that we have out there has a different priority to it, a different sensitivity on how fast it gets to the other side, a different sensitivity if packets end up getting dropped. There tend to be different sizes, right? So our phones, our VoIP systems tend to have really small packets and it's sending a lot of them out, but they're really small. Where video are a little bit larger. Our data packets tend to be larger than that. So what classifying is to trying to get that data, trying to get that voice packets, trying to get those video packets, trying to get whatever it needs to be categories or classes, we need to somehow get them into those categories, somehow classify that data. It may be based off of some sort of application layer hint that we have, some sort of port maybe that it's using. It may be based off of a physical port. It may be based off of a LAN or a local area network that it's coming from. So it could vary differently, but we need to classify that data somehow so we can treat it differently. Once we've classified that data, what we may want to do is mark that data. And so here we have a phone system right here, or a phone that's making a voice call, and it's creating packets that need to go across this network, maybe to this laptop, or maybe there's another phone over here that it's communicating to. Now, if this switch right here classifies this as being voice and priority, and so it sends it immediately to this router, the router is going to somehow need to know that it's priority as well. If it doesn't have any kind of marking on it, it's just going to assume that it's regular, just a regular packet, and it's going to send it along its way with the first in, first out. It's not going to prioritize that in any way. But what we can do is what's coming into the switch is we can actually mark it as this is priority. So when router 3 gets it, then router 3 says, oh, I need to send this first, sends it to router 2. Same thing, router 2 can look at it and look at the marking and say, oh, this needs to be prioritized. Send it to router 1 right away. Router 1 takes a look at it, oh, this is priority, and sends it to where it needs to go. So this is marking. This is the advantage of marking. What marking does is allows us to communicate across the network and prioritize those packets across the network according to their classification. So where does this get marked? Well, we actually have fields right here, this DSCP field right here, it's 6 bits long, that we can use to classify the data that's going across there. So we can reach down into this layer 3 packet, insert the information that we want to insert, so that way other devices along the path, every hop along the path, can prioritize this particular packet. Next, we have congestion avoidance. So as these packets are going across here, there's going to be other packets from other devices that are going to be going back and forth across here as well. Now, what we want to do is if there is going to be an issue, it's kind of like gridlock on a city street. Traffic builds and builds and builds, and it flows okay until it hits a certain tipping point. And then once it hits that tipping point, just everything gridlocks. Nothing gets, no traffic can really get around, and it's really slow for hours. The same type of thing can happen on your network. And so because of that, we want to drop some of these packets early. So congestion avoidance allows us to identify which packets are we willing to drop that are not as critical. So that's congestion avoidance. Then we have queuing, and your devices are going to automatically queue. And so what I mean by that is your devices have a buffer. So packets are going to come into it, frames are going to come into it. It's going to store that frame until it has a chance to take a look at the MAC address. It's going to store the packet until it has a chance to take a look at the IP address. So it's going to store that for a certain amount of time. And then what it's going to do is it's going to queue that into a buffer to go along, to be sent along the way. And so queuing is going to be just a part of of what your devices are going to do. However, what we can do is there's different types of queuing that we can utilize for QoS. So we can implement different types of queuing. So we're going to get more into that into one of these videos, but queuing is just a way to set it up for sending it along the way, store it for the period of time until it's ready to send it along its way. One reason why queuing has to happen is because you don't have consistent flows of traffic through your devices. You may get a period of time where you get very little traffic, and then followed by a period of time that has a ton of traffic, and then followed by a period of time that very little traffic again. And so we have to have some queuing to meter that to a certain degree. Then we have scheduling and shaping. The scheduling of when it's going to actually get onto the wire, and the shaping, we're going to talk more about shaping towards the end of this module, but it's a way to actually help get this information across the network without packets getting dropped. So here's the tools that you have to implement QoS. It's not an all or nothing type of deal. We can be selective with that. In fact, actually, what I mentioned is that queuing already is going to exist on your equipment, But we can implement better queuing. So we're going to talk about different levels of queuing or different methods of queuing that can make this more efficient. Same thing with classification. If we want to do some more advanced queuing, we have to classify that traffic. And so what we would do is some way to classify that traffic on what is the priority, or how are we going to treat those different queues. We may want to do some sort of marking of the data at the beginning of the network, so as it's traversing in the network, it's handled all the same way throughout the whole network. So we're going to get more in depth into this in the following videos. Just know that some of this is automatically implemented on your networks to a certain degree. Some of it is going to be stuff you have to configure on your network. Some of it is going to be stuff that is optional to configure on your network. There you have it. So we talked about those QoS tools. We talked about classifying, marking, policing, and selective dropping. We talked about queuing. We talked about scheduling and shaping. We're going to get more in depth into each one of these. And then finally, we mentioned about tool selection, where with each one of these, we have several different variables, several different ways to play around with this to implement QoS.